Day 2 of BSides Vancouver. I'm really excited to have Eleanor Saitta here with us. And sorry, getting distracted here. She is the principal security consultant for Systems Structure Limited, which is a boutique security consultancy that deals almost exclusively with fractional CISO services for Series A, B, and C internet companies. She has been in the for 20 years with various consultancies such as IOActive and Bishop Fox, did a stint as the security architect for Etsy, and has spent 5 years supporting NGOs that were targeted by nation states. So has a wealth of experience to share with us. And I'm just going to hand it off to her. And thank you very much.
Thanks, Andy. I'm super happy to be here. So today I'm mostly going to talk about systems thinking for security, and we'll get into a little bit in a second what that means. But because it's been, at least for the Americans in the room, an interesting news day, I've got some other stuff that I want to talk through a little bit as well, just because, I don't know, it's not really in the headspace to just give a straight systems theory talk today. So when I say system in the context of really most conversations, but especially talking to security folks, I'm talking about a system that exists to do something in the world. And so this means, yes, a set of applications, yes, a set of computers, et cetera, but it's also a set of business processes, right? It's a set of all of the things around that system that actually make it deliver outcomes in the real world, not just kind of this thing off to the side that's, that's just doing a technical thing. It's about the thing in the world. Now, to be useful, a system needs to have certain properties, and these are properties that come from the entire system operating together in a specific context. And just jump ahead and look at, so these are properties like correctness, right? If the system doesn't do the thing that you think it's going to do, then it's probably not going to, going to have the function in the world that you expect it to. Performance, right? If a system isn't sufficiently performative for for the problem it's trying to solve, for the money that you can afford to run it, et cetera, then you have to fix that, right? You have to have you have to have it have enough performance, enough efficiency, et cetera, to actually meet the problem domain and accomplish those goals. You probably need to know what the system is doing, and from our perspective, you need it to be secure, and also resilience. We'll talk about resilience a little bit more later because that one's a bit more complicated. But so all of these are properties that emerge from the entire system running in a context, right? You can't say that the correctness of one component in a system is not the correctness of the whole system, and the correctness of the technical system is not the correctness of the system operating in the world, right? That's the that requires the human parts of the system as well as just the digital parts. And all of these things are things which require unified effort across a bunch of teams to deliver, right? No one team can deliver efficiency, no one team can deliver performance, et cetera. All of this stuff is hopefully fairly obvious. So now let's talk about what security is. A lot of us are kind of coming from a mindset where security is a specific property of technical systems, right? You can say that, oh, this web front end is secure, it has no cross-site scripting attacks. Except I think that that's actually not a very useful understanding of security when we look at the work that we're actually doing, right? Because what we're actually trying to do with the system is to enable some set of people to predictably accomplish their goals in the world, right? That's what we actually care about. We don't actually care about cross-site scripting. We care about what this thing actually does. And we expect them to be able to do so in the face of a chosen set of adversaries. I say chosen set because you probably are not going to, in most cases, build a system that says no one in the world can possibly interact with this in a way that we don't want, because you don't have the budget for that, right? You're looking at the set of adversaries that you think are relevant to the work that you're doing, are likely to actually be attacking you, and also the set of adversaries that you can afford to defend against, because you can't afford to defend against everyone. And oh, did that font get cut off? Yeah, it did. anyway, so predictably prevents that chosen set of adversaries from accomplishing a separate set of goals, right? So this is, an adversary doesn't care about stopping your users from doing anything, but they want to use your system to mine Bitcoin or do whatever it is they're doing this week, right? So it's both the positive, the chosen users can accomplish their goals, and a negative, the other people can't accomplish their goals using your system. And so, and this is a definition of security that we can actually reason about more directly. We can say, is a system secure with respect to a set of goals, even if individual components are compromised, right? And reliability and predictability and correctness here become interesting. Where we know that all components eventually probably have some set of vulnerabilities in them, and that's fine. Well, or it has to be fine because we don't have another option, right? So another way of saying this is that it's about reliability and correctness of outcomes in the presence of an adversary, and it's also about defense of those outcomes, right? Because it's not, this is the security as a process, et cetera. So there's kind of, again, there's two components here. And this is interesting when we start talking about resilience. So if you find this next bit interesting, I'd recommend looking up some of the work of the Resilience Engineering Association. Resilience is basically the ability of a system to deal with failures that no one was expecting, right? We are relatively good at this point in engineering of saying, okay, yes, we have fault tolerance, we have failover, we have backups, et cetera. There are a bunch of categories of failure, of modes of failure that are foreseen, right? That are expected, right? We expect that we might get data loss in some context because we know it happens enough, so we have backups. We expect that that individual nodes will crash, so we have multiple of them. We expect that DDoSes might happen, so we have load balancers and upstream filters, et cetera. So we have these predictable failure modes. Resilience is when you have an unpredictable failure mode, and this is often any real compromise generally becomes, or often becomes, a resilience exercise unless you're in a team that's big enough that dealing with compromises and kind of the flow of individual compromises becomes predictable, which is honestly pretty rare, because if you can predict a compromise mode, you probably fix it, and instead of having to deal with responding to that same incident again and again. Now, this is interesting because resilience is not a property of code, right? Resilience comes from the human team who is managing that system. And when we look at designing for a kind of a resilient security, right, a security that can allow us to deal with more of the unforeseen, we can look at this from sort of a principle-centric approach. And this is something that I've been spending, it's been probably like 15 or 20 years in some ways thinking about now. And it sort of started from looking at kind of CIA and, the CIA triad and some of those existing kind of models for how do we think about modeling the security of an application, and realizing that actually these kind of fail to capture as much as they do capture, and they're not very good for they're not very good for reasoning ahead of time about the security properties of a system, right? And even when you think about it at the requirements level, how do you specify that a system must be secure? Well, often you have the technical design doc, and there's a section at the bottom that everybody leaves blank, which is security, and everybody leaves it blank in part because they don't really know what to put in there, and they don't really know how to think about this structure. So this is this kind of principle-centric approach is my approach, or a start of an approach at how do we get better at thinking about security ahead of time? How do we get better at doing the kind of design and architectural work to understand if the system that we're about to build is going to end up being fit for purpose? So I'm going to stop here a little bit because it has been an interesting political day. And as security engineers, we're all responsible for the impact of our work on people's lives. This is especially important when we are in a situation where the security environment of the kind of the world we live in is changing pretty quickly. Now, a lot of companies will decide that, well, we're willing to overlook this harm, right? We're not willing to spend more than X effort to protect our users, or it's more important that we reduce the friction to people signing up to our system than it is us, ensure that our authentication is sufficiently strong for the purposes that we're aware that people are using it for. I would argue pretty strongly that it's maybe time to start thinking about some of those things a bit differently and to push back a lot more. We're looking at a situation, and like, I would say that this is probably going to be as true in Canada as it is in the US sooner than any of us would like. We've got a lot of systems that were designed for operating in an environment where they were fundamentally working under the rule of law. And they're now going to be operated outside that scope. We've made a lot of assumptions about lawful intercept is lawful. What happens when it isn't? And I would say that our responsibility to think about the impact of our actions is not just for mitigating known harms. It's for looking at harms that are probable. It's for looking at the structure of our work in that kind of larger context. And this is one of the kinds of places where this way of thinking about things from first principles, I find, sort of clarifies a lot of stuff. So I want to talk a little bit about, when we say you've chosen a set of users, right? What are the goals of your chosen users, right? And not the goals with them using their system, but the goals of they're trying to do things in the world, right? So let's say you run a chat service, which is sometimes used for social stuff and sometimes used for work stuff. So here's a few personas that you might think about examining in the context of designing that chat system. Say you are a domestic violence victim seeking an abortion. Say you're a queer teen. Say you're a union organizer. Each of these is interesting because they break some of the expectations that we have when we're designing systems, right? If you are looking at doing authentication for a system that will be used by domestic violence victims, and I can guarantee you, if you are designing a system that uses authentication, you are designing a system that a domestic violence victim will be using to authenticate, simply because these people exist in lots of contexts. This is not, you can't say, oh, well, we're not social, right? We're a web shop. We don't need to think about this. Well, you probably do. And this is an interesting one because it means that you can't, for instance, assume that the user has control over their devices. You can't assume that the user has reliable control over their email address. Somebody else might be able to send mail from that address. Somebody else can almost certainly read email from that address. And I know in a lot of cases that sounds like, well, this is impossible, right? We can't possibly do anything here. Except you can, right? So let's say you've got, you're this chat system. Well, so let's say you support deleting messages. Great. Do you leave a tombstone for those messages, right? If you look at a chat log after the fact, do you see so-and-so deleted a message, so-and-so deleted a message? Do you need those tombstones, right? Maybe you make those vanish. They show up for 30 seconds just so that kind of the user knows what happened to smooth over the UX, and then they go away. So if you look back at that chat log in 2 hours, you can't see anything, right? That means, because at the end of the day, that user is going to be trying to have some conversations moment to moment, right? And they may know, okay, I've got 2 hours where I know that the person who I'm trying to stay safe from won't be able to read this chat log. Okay, I can now use this tool to go have a quick conversation to, I don't know, arrange an exit, do all sorts of whatever, get support, any number of things. So things like account recoveries, understanding, are there other sessions currently logged into my account, right? Facebook has actually gotten pretty good about this. You can see, oh yeah, here are all of the sessions that have accessed this account, that are currently accessing, etc. There's a nice button, log out all the other sessions, which makes it pretty fast to do an account recovery, to say, okay, log out all the other sessions, change the password. Okay, now change the recovery tokens, change which email address something's associated to. And obviously this goes both ways, right? That means, if you make that easy, then it's easy for anybody who does have access to that account. But, this is where we look at, some of the kind of interactions where that abuser is probably not necessarily trying to eliminate access because they want to retain long-term access. Queer teens are interesting when we think about parental controls, right? We spend a lot of, if you're designing apps for kids, there is a lot of concern into like, okay, making sure that parents can see things, etc. But, that's not necessarily actually always going to be useful, and figuring out how do you balance those different needs. Like some of the first round of the Apple CSAM reporting system, where they were going to do client-side scanning for anything that might be CSAM on devices owned by kids. And the first version of that was, and then we'll send it to your parents, on the assumption that, well, yeah, the parents are a trusted party who should know what's going on, except now you've built a machine that just outs people to their parents. And now they do something of like blurring the content by default, and suggesting access to resources so that folks can still be protected against some of this kind of stuff, but there isn't this kind of there isn't this structure that will magnify and literally create instances of abuse. A union organizer, right? This is I think most of the folks doing union organizing at this point, well, yeah, you don't use company Slack because we know that the company Slack has all of us in it. And we may have been told by, somebody in corporate to take a look at stuff or hand certain things over to legal, etc. I don't know. Do you want to always have everything internal logged in all contexts? Do you want to set up so, and Slack has done this, right? Where the default is DMs are actually private, and you have to tell people if they're going to get turned on, right? Slack hasn't made all great choices everywhere. It'd be nice if they had like some anti-abuse tooling in there, but that is a great choice where by default, not everybody does have that access. So I think this is something where, as we think about the tools that we're building, as we think about what they actually mean, it changes our understanding of the products we build, of the way we respond to different kinds of security situations, etc. If you have a customer service context or you have an abuse line, etc., you probably do need to be in a position to deal with abuse victims from a bunch of these kinds of things, from a bunch of these kinds of personas who may end up, in some situation where they're stuck, and because of their situation, they don't have recourse to the usual channels. And this is just kind of one little corner, right? These are illustrative personas because they show us a lot of the assumptions that we make are not necessarily going to hold true for all of our users. But this is not sort of the total set of context that you need to consider, but it's a start, and it's a start at kind of getting away from some of those baseline assumptions and looking at what do our tools mean when they're used in contexts we don't expect. And I think that as we start looking at more and more authoritarian countries, and possibly much more of the internet becoming more authoritarian and becoming policed, and many more people needing recourse to private communications, needing recourse to being able to remove data about themselves, being able to not be caught up in surveillance. A lot of our jobs are going to get a lot more complicated. because the harms that we're called upon to balance are not going to be as straightforward, and we may also be in positions of, well, there's a lawful access request for data that you hold. It's a system that we've designed so that there aren't logs of internal data deletions. Which lawful access requests do you respond to? Which do you not? And kind of understanding what the direct cost to humans who've trusted you to enable them to do the things that they're trying to do in the world is going to become more and more important. Unfortunately, for probably pretty rapidly. So, sermon over. I would really like to live in a world where we needed to think about some of this stuff less, but unfortunately, that's not the world we live in. So let's talk about how we do some of these things around designing for resilient security. The first 4 of these principles are heavily tied together, and we'll kind of run through them. And I think hopefully I'll give you guys a bit of a feel of how this kind of principle-centric thinking works in this in the context of this kind of systems analysis. So, state and logic, right? Services should either do computation or hold state, not both. And this is, I think probably familiar to some of you who've looked at 12-factor apps and all of that kind of modern, sort of more modern dev principles. But from a security perspective, complexity is basically enemy zero, right? Every increment of complexity, you've got this exponential curve of how difficult it is to secure a system, because all of your components interact with all of your other components. So the simpler those individual components are, and the simpler the interactions between those components are, the easier it is to understand what your system is actually doing. Some of this gets into the kind of weird machines territory. Show of hands for how many people are familiar with that phrase. I know there's a bit of a delay, so I'll keep talking. But this is basically saying if you have a service that does computation, right? If you have a web service, etc., it should be completely stateless. If you have to have backend state, put it in a separate cache layer that, it can be a sidecar, it can be whatever, and just make sure that you can decouple these and that they're inspectable, right? If you have a separate service that's holding your state, you're more likely to be able to, go in and inspect, et cetera, than if it's just like, well, we have a big blob in memory, which is all of the state that this service instance is using. So I'll explain the weird machines thing. This is, Len Sassman, I think, is the original credit for this. It's basically the idea that every machine, every piece of software has a unintended function that, its intended input, its intended outputs. But most pieces of software also have some weird functions where if you send it some unintended input, you get unintended outputs. And this is just kind of another way of describing, it's a vulnerability. But if you think about, well, we've got a bunch of APIs that are stitched together and they're all mostly correct, but, some of them also will do other stuff sometimes. It makes it more likely that an adversary can stitch together a machine that does something that's useful to them. Out of those normal machines and their weird functionality, they can build a weird machine that lets them accomplish a goal in the world. So getting away from this kind of complexity makes it less likely that you accidentally build useful weird machines. So now, immutability and ephemerality, also relatively familiar ways of thinking about systems at this point. Now, the way I like to think about this is that, okay, obviously data is state, right? Cache is state. Configuration is also state. Memory is also state, kind of obviously. If your systems are immutable, then you eliminate state that is not necessary, right? Because if I can't edit a thing, right? If I can't change a thing, then it's not actually state. It's just the structure of the thing. And you can look at limiting kind of the scope of editability of state in terms of is configuration editable inside a container, or is it, completely read only, Or, can I change things? Okay, that's one way of eliminating state. You can also look at eliminating state on a time scale, right? So every time you respin a cluster, you've now reset the state of that cluster, right? Which is another way of limiting the scope that an adversary could potentially edit and change the state of that system. So we also want kind of minimal canonical state. Ideally, every single piece of state should exist canonically in exactly one place, right? So this might mean that, for instance, in an ideal world, the entire configuration of your AWS environment would live in GitHub. Great. Now I can validate and verify that, or now I can assume that AWS always has this state, assuming my deployment system, only goes in one direction, assuming my, I never make changes in production. And so, in theory, I've got, okay, GitHub is master and AWS always matches that. Now, in practice, you actually do have duplicated state because you can't ensure that AWS can't be edited. So now you have to validate it. But you do at least have an authoritative copy of what that state is supposed to be, which means that it's possible to validate it, right? If you only have your non-canonical, non-versioned copy sitting in AWS, validation is manual. Validation is look through this thing. Hopefully you can find all the pieces of state and then try and validate it. So as few places as possible should be stores of state, right? This is kind of an underlying reason for immutability. You don't want those additional state stores. You don't want to have to think about configuration drift. All of these are sort of opportunities to introduce unintentional vulnerabilities. And what this fundamentally gets back to is this is kind of a version of least privilege, right? If mutating state in production isn't required for the system to do the things that it's trying to do in the world, then it shouldn't be possible. This is still true even if there's no intentional interface to allow users to do this, because attackers may be using unintentional interfaces, right? So you still, it's a kind of an iterated version of least privilege where you're looking at privilege, even if those things, even if those, those interfaces, et cetera, aren't intentionally created. So this is maybe it's kind of a chain of things of looking at state in systems. And this is, it's just a sort of a few little principles off in a corner of but it has implications for the larger way we think and reason about systems. And the whole goal of this entire chain of things is to reduce that structural complexity, to simplify the system, to make it more predictable, to make it easier to reason about. I'm going to talk about one other principle at the kind of component level that's more technical, which is unlinkability. So obviously, there's a lot of folks talking about privacy. There's a lot of systems like Tor, et cetera, that are trying to create anonymity. One of the things that I've found in, again, in a while of looking at this in contexts where it's mattered, is that it's often very difficult for engineers or teams to define what they mean by anonymity. And so I like to think about it as unlinkability instead, because this is something that we can actually analyze in a meaningful way, right? If, a piece of data like this user clicked on this link, right? So you've got a user identity and an action, right? And if you can say, okay, this IP address, right? We're using IP addresses as a proxy for identity here. So this IP address is unlinkable to this link click under some set of assumptions that, like the adversary isn't on the local network, that less than X% of the nodes in this onion network are compromised. So this is basically a way of reasoning about where you do and don't want to have specific kinds of sort of structural leakages and structural linkages. And in general, I would suggest that in a lot of contexts, it's useful to actually actively define this about which things you are and are not willing to be linkable, and also to whom. For instance, if you have some random web application that has a bunch of SaaS services that it interacts with, and in some of those, you're going to call out with like, oh, I've got a user ID and some piece of data that they're going to, look up, send somewhere, process in some way. Does that user ID need to be the same user ID that you use internally and that you use with other vendors, right? So let's say you're comfortable with the privacy impact of using this vendor separately and this vendor separately. So you've got these two vendors. Each of those pieces of data, it's acceptable to have out in the world separately, but maybe it's not acceptable to have both of those pieces of data together, cross-linked. So if you use the same user ID for both of these things, then if those two sites get a breach, a third party can combine those two data streams. And this is using a non-opaque identifier like email as your key that you send to the third party, or using the same GUID for all the third parties. Whereas if every vendor gets a separate GUID for the same user, so that you've got, here's our GUID stream for vendor Y, our GUID stream for vendor Z, etc., then it doesn't matter if those breaches happen. It doesn't give the adversary the ability to cross-link those pieces of data. So yeah, this is kind of, and I'm not claiming right now that this the set of principles I'm talking through here are a complete set of principles for designing from a systems thinking perspective. More that they are these are a few interesting principles. I'm trying to not keep you guys here all day for this talk. So let's talk a little bit more now about process principles. And these are more about how we do the work, how we interact with the system, how we work as teams, than it is about the specific technical components. So the first one is looking at declarative versus procedural logic. In general, if you can configure something declaratively, it is going to be much easier for both humans and sometimes also the computers, but especially the humans, to understand the end state of the thing, right? So you have state A, you apply a configuration, you end up in state B. If you declare that configuration, then you can generally look at state A, look at the declaration of the transition, and understand, okay, this is what state B is going to look like. If you have a bunch of for loops that iterate over various things, figuring out, okay, what's the end configuration is often very, very difficult. And this concept applies in a bunch of different places. So for instance, if you're looking at a parser, right, you're receiving something in off the network, and you need to make sure that it is well formed, and you need to understand, like, okay, here's the set of elements that we're trying to get from this. You've probably got an idea of you've got an example data, right? You've got the thing that you're expecting to receive, but understanding whether or not the parser that you wrote actually matches the spec that you have is incredibly difficult, right? That is a very hard comparison question, like actually both for computers and for humans. It's not just hard for humans. So instead, if you say, okay, we're going to write a spec declaratively, and then generate with a tested parser generator a parser that will that will just accept those things, you're much more likely to end up with a parser that doesn't accidentally accept something weird. And this kind of goes back to the weird machines. The second to memory issues, parser issues are kind of one of the most common classes of vulnerability. XSS, all of these things are all fundamentally parser issues, and we still haven't got, we're still letting people write parsers by hand. And when you look at, say, oh no, we don't need to worry about parsers because we've got JSON now, right? And there's a nice, validated JSON parser built in, but you write JavaScript, and so you accept an object, and that object has some structure. Does it have the structure that you expect it to? If you use a strongly typed language, you can actually make some assertions. We've declared the structure of this object, right? We've declared the allowable structure. And now, throw the JSON in there, throw it, okay, type error, right? state machines are another context. The number of times, both like looking at all the platforms that have had IP fragmentation issues, and then the number of times that we've reinvented that problem in different places in the stack, like SIP fragmentation. Okay, now we've built a messaging system on top of IP, and now it needs to and we have the same 90s fragmentation issues. If you have a state machine generator that simply drives that structure, it lets you get an outcome where you actually can say things strongly about, no, you can't enter in an illegal state. The system won't allow you to skip this step. And this doesn't have to be a formal methods world thing, right? This doesn't have to be something that's like, it's not just an aerospace world thing. Using a parser generator is faster than writing a parser. Using a state machine generator is faster than writing a state machine by hand. Obviously, there's a little bit of overhead. You have to learn the library. The first one might be slower. The first 5 might be slower. Once you get through that place, it is a lot faster, right? But this is also Terraform, right? This is also infrastructure as code. It's saying, I declare that I want this to be the state of my ecosystem. Figure out how to make it that, rather than run this set of commands and hopefully it ends up in the state that you want. A lot of this is basically let's build systems in a way that allows humans to actually interact with them in a reliable way. Let's make things as easy as possible for the computers, but also for the humans. Designing for failure, right? I don't know how many of you, when you're kind of, especially if you're looking at like a relatively greenfield security environment where you're standing up a lot of stuff, we generally kind of will do a little bit of designing the system we'd like to have, but then it's like, oh, well, but we really did need, we needed a forensics environment. We needed a whatever. The being able to say that, okay, we know that for at least the kinds of compromise that we can foresee, we have these tools in place, right? Instead of saying, well, we've got a control for authentication, we've got a control for data backup. We don't have a control for data backup in the context where the authentication system fails and allows someone to go delete stuff. So designing with the assumption that any given layer is probably going to fail. And sometimes the answer may be, well, we can't actually completely duplicate this layer. Like, we don't have a way of saying, oh, well, no one can delete data if, because the auth system might fail. That's not viable. Fine. But you say, okay, well, we keep backups for 30 days, even after deletion. They're only accessible through some other process, and then, okay, we have to balance versus lawful intercept if somebody really needed that data gone. Like there's trade-offs in all of these directions, but just assuming that kind of compromise is inevitable in the same way that we assume that, a given component, a given node is probably going to crash at some point, right? So this is, we're getting now more into kind of the actual resilience side of things. So one of the things that we've seen when looking at resilience with teams operating in high-risk situations or kind of high consequence situations. And so this is stuff like, yes, it's ops teams, but it's also like hospital operating rooms, flight decks, these kinds of places, is that it's often very critical for safe outcomes, and I think also for secure outcomes, with some caveats, that decisions are happening closer to the edge, right? That the person who is deciding, is a thing safe, is a thing functional, is the person who's actually engaged in the full context of the work. And that means that you need to be focusing more on coordination and communication and less on central control, right? And in some cases, this might be saying to a, to a development team, this is the set of things that you can deploy without any oversight. This is the structure. This is, I mean, let's say we're thinking about reliability or efficiency. Like, you can go, you can spike 2x or 3x or 10x over your normal compute budget, to keep the system up, right? We're fine, we're fine taking that cost. At some point, we need to kind of, tie it in, but getting those decisions closer to the place where there's context is really useful. What you need to do this is you need thick horizontal relationships, right? And this is what I was talking kind of at the beginning about needing, these are, any of these kind of emergent properties require the entire set of people working on a system to operate collectively. This is the, well, you can't ship a secure system if the dev team isn't also trying to ship a secure system. And that means that the dev team needs to know who security is, because they're going to have questions, right? And like, yeah, you can have your security champions program and you're this and you're that. But like, for instance, at Etsy, there were a bunch of healthy snacks in the building, and then security had candy, right? And a whole lot of people from a whole lot of different places would show up and come get candy from security. And that meant that literally, like, we knew a bunch of people in a bunch of different contexts that we wouldn't necessarily have known otherwise, just, for those kind of social reasons, which meant that it was much easier to go and, like when somebody had a security question, they probably knew somebody on the security team well enough to kind of lower that bar to just, ping them on Slack, etc. And we could get that kind of thick communication, decentralized coordination, not top-down control, which allowed for better response, etc. when things did go kind of outside the bounds of normal operation. Prioritize replanning. This is, again, like, this is something for resilient systems in general. I think it's especially true for, things like incident response. We know we end up doing this a bunch, but also for, looking at like major security initiatives, etc. Right? We know that, you make a plan mostly to have something to destroy as soon as you start work. You could basically guarantee that that plan is going to change. Now, that means that you need to be like, you need to focus on replanning instead of focusing on like making that initial plan as heavy as, as correct as possible. And this is, I think one of the things that, like, at the sprint level, we've gotten better at this, right? We're kind of used to replanning on that context. We're not necessarily used to managing resynchronization as stuff changes across teams on a sprint by sprint basis. And we're definitely not good at managing this kind of replanning at the structural level. I have yet to see a large dev org that could reliably do reorgs without someone quitting, and that to me feels like, given that we know that reorgs are inevitable, we know that replanning is inevitable, we know that shuffling goals is inevitable, that seems like a pretty big, failure, given the way that we know we have to work in a resilient scenario. And I think as we're looking at our threat environments changing, our, the meaning of our systems changing and changing fairly rapidly, this is going to have an impact on the, on security teams more and more directly. Just to answer the question on balancing decentralized decision-making versus having a single source of truth. What I'm talking about here is the decentralized decision-making in the context of the engineers doing the work, not necessarily, like, I'm not saying that, there shouldn't be still a single source of truth, but I think that this is one of the things where if you have as a principle, like, that's kind of accepted, that we will always ship systems that have a single source of truth, then it's basically a forcing function, right? That principle exists as a forcing function to say to those two teams, like, look, you can figure this out directly, right? You're empowered to go make that decision between the two of you. You probably also required, as as kind of the caveat to that power, to go find the other stakeholders. But that doesn't mean you get to bend the principle, right? You still have to say, like, one of you two has to win. And ideally, you're in a context where you are on the same side and you're not dealing with, inter-team or inter-dev org infights about, territory and power, etc. But if you are, you should probably solve those instead of bending the principles for your system design. And this kind of gets into the, like the incentive structure that you design in your organization is going to determine the applications that you build, right? The reason why AWS has so many services is that above a certain point, you have to launch a new service to get promoted. This is a very dumb way to design a cloud ecosystem. We should perhaps not do that. So one last one, Slack, right? You cannot resiliently respond to out of context problems when you have a team that hasn't taken vacations in 3 years, where everyone's working 70-hour weeks. This means, you need to have big enough on-call rotations. You need to make sure people actually take all of their vacation. You should be tracking out of hours work, especially for SecOps and Ops teams. And you should have like actual caps on how fast you're actually going to try and change stuff. Anytime you're trying to improve these kind of emergent properties across whole systems, it is going to take more time than the bare minimum. And anytime you get outside of kind of planned outcomes, you're going to end up asking your team to put in a bunch of additional work. So in both of those contexts, you need to make sure that the teams actually have the time to do the work that they need to do for those properties, not just for the bare minimum correctness, but also that when you hit a wall and all of a sudden it's like, okay, we've got a bunch of stuff in the logs that shouldn't look there. This looks serious. Everybody cancel your weekends. That people aren't just like, I'm just going to ignore that message. I don't really care. They can fire me. That is not a thing that you want to find out, that you have your teams in that state during an incident. So you at very least need to know where they are, and you probably need to actively manage this stuff. And I know that a lot of folks in security, and I've been in this position myself, end up with this kind of superhero mentality of like, this is important, we're going to save the world. Yeah, it doesn't actually fucking work. All you do is get burnt out and not save anything. So take your vacations. Anyway, if this stuff is interesting and you aren't in security and have a startup, I'd be happy to talk to you about how you build a security team from zero. And I'm also happy to talk through questions.
All right, thank you very much, Eleanor. There's one question here: is how do you deal with unlinkability over multiple degrees? So two pieces of data that can, with a link that can be inferred through a third piece of data.
Yeah. I mean, I think it's going to depend on the context of how specifically you want to tease those apart. In general, switching from shared identifiers to opaque identifiers, moving to systems where you send transformed information instead of raw information. All of these kinds of things let you start teasing it apart. But it's really gonna depend on the specific context. There's been a bunch of work on some of the kind of like privacy preserving matching systems where you have a certain privacy budget, etc. Some of that work turns out to maybe not actually work as well as we thought it did. Like there's a whole evolving field there. But honestly, even if all you look at is the identifiers you use, where they go to which third parties, what data you actually need to send to those third parties, what data you can avoid, and in general, basically treat information as a cost, right? Every piece of data that you store, send, use, share has a specific cost, and kind of try to minimize that cost yourself. You end up kind of minimizing that risk. If you have more complicated situations where you need to start looking at interesting crypto and stuff, et cetera, I'm happy to talk about that offline, because those problems get super fascinating, but there also aren't general answers.
Thank you. How do you balance decentralized decision-making with having single sources of truth for state? For instance, two teams
I already covered this a little bit earlier, actually.
I missed that.
Yeah, no, I think it's basically, this is a question of making sure that making sure that you're doing your design intentionally, making sure that teams are actually talking to each other, and also making sure that your system architecture isn't determined by politics, which I know is incredibly difficult in a lot of contexts. But I mean, one of the things, I'll pick on AWS some more, but I think a lot of cloud providers are doing this right now. Complexity is lock-in, right? And so there is no drive to simplify our cloud stacks, because you give people a lot of individual canned features that map very directly to user problems. It's faster. Hey, talk to your AWS rep and they'll tell you how to fix this. And I mean, in a lot of cases, I could say the same thing about GCP and Azure. Whereas if we think about this from kind of an emergent complexity structure, actually we need to be flattening stuff a lot, right? We need to, the number of layers that we kind of stack on top of each other, each one of those layers has some set of unpredictable failure modes. And obviously it's not a trivial thing for us to just go out and let's redesign, let's just boil the entire ocean, redesign the world in one go. But at a certain point, we're going to have to start kind of knocking out some of those layers, flattening stuff out, et cetera. Or, we can't just keep adding cruft on cruft.
Thank you very much. I think that's it for the questions that I've seen pop up here. Give anyone a last second here.
Yep.
If not, thank you very much for the presentation. You covered a lot of really important topics and gave a lot to think about as well. I know that I at least have a few new questions to add to my repertoire when dealing with clients. So I really appreciate that. Thank you very much for kicking off day 2 of BSides Vancouver, and to everyone who's watching, please enjoy the conference. We've got a number of fantastic speakers lined up for the rest of the day. Big thanks again to our sponsors who helped us put this on. We just can't do it without you, so we really appreciate your support.
Thank you very much for having me.
Thank you. Bye.